Good afternoon, everyone. How are you? कैसे हो आप लोग? Tell me, is everything clear? Everything visible? My screen, my voice, is everything okay? Everything fine? So, how it feels like? I think summer has started here. Okay. So, up to the previous session, up to the previous lecture, we have completed fluids. So now we are going to start thermody and kinetic theory of gases. So in this lecture, in this particular lecture, we will start with thermodynamics. That's a most important topic, most important chapter, you would say, that for the point of view of the mains as well as of the advanced. Because every time, every year, in every shift, there are questions from this chapter. So I think you need to be very well prepared about this chapter, and no one should skip the classes because this is a very fundamental and very important chapter, thermodynamics. So we will start with the thermodynamics. Let's wait for 1 or 2 minutes more so that everyone can come and join the session. Okay. Hello, JNV. P. I don't know the full name of this JNV. Anyways, I hope you have studied the previous lecture. So now we will start the thermodynamics. Let's move. So first of all, what we will see in this lecture, we will define what is thermodynamics. After that, we will define some thermodynamic system. Some basic introduction is today. We will give some introduction. After that, we will start by the work done by a gas and the indicator diagram. These are the two important things to be understood for the rest of the chapter. So first of all, we will introduce the chapter. What is thermodynamics? What are these? What is a system? And these small things are very important for the understandings. So let's start. What is thermodynamics? So I have written here the thermodynamics, the term thermodynamics. You can see if we can break this term out. Thermo, you know that it is related with it is something related with the heat, and dynamics is something related between with the motion. So thermodynamics is what is the transfer of heat between two bodies or the exchange of heat between two bodies. That's what thermodynamics. One more thing that we can learn, JNV Pune. Okay, JNVP is for JNV Pune. Very good. One more thing that we can associate with the thermodynamics. Okay, thermodynamics, one thing is that the exchange of heat between two bodies. One thing more, the conversion of heat from energy to the work done is also comes under the thermodynamics. So there are two things. One is transfer of heat. Another thing is conversion of heat into the mechanical work or vice versa. So in the written form, if you want a written definition, then the definition is here. Here. It is a branch of science. You can read it out. It is a branch of science which deals with the exchange of heat. Exchange or transfer is the same thing between bodies and conversion of heat into mechanical energy and vice versa. Mechanical energy, you will say kinetic potential energy, or you would say the work, and vice versa. So this is what thermodynamics is. If you see in the later section of this chapter, or if you have studied it in your school, we will learn about refrigerators, we will learn about uh, heat engines. So what's happening there? The heat is doing some mechanical work. what's happening here? Heat is doing some mechanical work. That's how heat engines work. So automobile engines, heat engines are the automobile engines. So thermodynamics is very much involved in most of the things in real life. In mechanical engineering, a lot of things depends on the thermodynamics. So this is a very important chapter. We are not dealing with the mechanical engineering. We are dealing with your section, with your class, and with your exam. So for the exam point of view, it is also very important. Moving further. Okay. So what is a thermodynamic system? Again, we are limiting our scope to your syllabus. Otherwise, there might be a very different scenarios for the thermodynamic system. So for now, what is a thermodynamic system? Just look at me. Uh, there are certain boundary. A system is what with which has a definite boundary. System is what which has some definite boundaries. So a definite boundary system which has large number of molecules, which has large number of molecules. For example, I have filled an oxygen gas in a container. I have filled an oxygen gas in a container. So oxygen gas, which has large number of molecules filled in a container. Now, if I filled the container with the oxygen gas, then there might be some pressure of the gas, some volume of the gas, and some temperature of the gas. So, what is a thermodynamic system? Look at that. Collection of large number of molecules confined within certain boundaries such that it has certain pressure, volume, and temperature. So, this is a basic thing. Now, these definitions are not that important. Now, what I say, listen to that carefully. Generally, in this chapter, how a system means, what a system will mean to you is like that, will look like that. What is this? This is a container which has some well defined boundaries. It is filled by some gas. In this chapter, we will deal with the gas. Otherwise, there may be a liquid, maybe a solid. Everything could be there. But in this chapter, what we will deal with the gas. And that gas is also ideal gas. And you know the concept of ideal gas. So I don't need to describe it. So this is ideal gas. So what I'm saying, a boundary, a system, a container filled with some gas, some ideal gas. And this is what a piston. This is a piston. Piston is what which can be moved up and down. And this piston is considered to be light and frictionless. So this is a thermodynamic system. In terms of definition, you can see what you can see. Generally, a thermodynamic system is a container filled with ideal gas and fitted with frictionless, light, and movable piston. Now remember, listen to me very carefully. What is thermodynamic system? Container filled with ideal gas, fitted with movable, light, and frictionless piston. That's it. That's our thermodynamic system. And if a gas is filled here, it will have some pressure, volume, and temperature. It will have some pressure, volume, and temperature. So that's not a big deal. Pressure, volume, and temperature. PVT. There may be certain values of PVT. Now, there are two more things that you need to remember. One thing is that the walls of this system may be of two types. The walls of the system may be of two types. One is adiabatic walls. Adiabatic walls क्या होती हैं? What are adiabatic walls? The walls through which heat cannot be transferred or heat cannot be exchanged. The walls through which heat cannot be exchanged. And then there are another type of walls, that is diathermic walls. The opposite of adiabatic walls is obviously through which heat can be exchanged. Heat can be exchanged, heat cannot be exchanged. So adiabatic walls, the another name you can give it to is that insulating walls. The simple name. These terms will be used later. So you need to remember those things. Diathermic walls, you can say conducting walls. I think everything is clear till now. What we have described what is thermodynamics, what is thermodynamic system. This is a thermodynamic system for you. Now, moving further, the types of thermodynamic system that we are going to describe. Okay, this is again, these are again the theoretical thing. You just need to keep these things in mind. There is no need to uh, learn a lot of these things, but you need to keep this in mind. Okay. One is open system. Open system is nothing but the system in which you can say energy and matter both can be exchanged with the surroundings. Both can be exchanged with the surroundings. There is nothing difficult in that. Closed system. Now you can define it by yourself. What is a closed system? The system through which energy can be transferred only, which can exchange only energy with this surrounding, but the matter inside it should remain intact. And there comes another type of system, that is isolated system, which is going to be used very frequently. What is isolated system? Through which neither can be exchanged. Neither means neither energy nor matter with the surrounding. You cannot exchange energy, you cannot exchange matter with the surroundings with the isolated system. I think these are the very basic fundamental things that is clear. Now moving further. Thermodynamic variables. This is again a very frequently used term in the books actually. So you should be aware of these things. What I have described to you, what I have told you, that there is a thermodynamic system in which an ideal gas is filled for our scope of the book. Ideal gas is filled. So it has certain value of pressure, volume, and temperature. These pressure, volume, and temperature, if you know the values of these three quantities, or at least two of them, you can define the state of the system. You can define the system with clear concepts. So these three quantities are known as thermodynamic variables. You don't need to look at the definition. What are thermodynamic variables? You will say, you will say pressure, volume, and temperature. These are the three thermodynamic variables. By changing these variables, you can change the state of the system. If volume is increased, you will say that volume is increased, the system, the piston was My visual or screen is visible to you, just comment actually. The electricity problem was there. So just comment whether it's visible to you or not. Write in the chat box, everyone. So we were dealing with thermodynamic variables. I hope it's clear now. We were dealing with thermodynamic variables. So pressure, volume, and temperature are the main thermodynamic variables. By changing any of these three, you can change the state of the system. That's what is written here. So you need to remember what are thermodynamic variables: pressure, volume, and temperature. Clear? Now moving further. The relation between these three quantities. This is very important. The relation between these three quantities is PV equals to nRT. This is known as ideal gas equation. Ideal gas equation. P is pressure, V is volume, N is what? Number of moles. R is the gas constant. T is the temperature. Everything is known to you. I think you have studied that in chemistry. So PV equals to nRT. This is ideal gas equation. Very important equation. This is going to be used a lot of times in our discussion. Moving further. Thermodynamic process. Now, this is again a simple term that we have described previously. So just don't worry. Try to be calm because next topic is going to be very important. What is this? Thermodynamic process. Thermodynamic process is what? Changing one of the parameters, changing one of the variables, at least one of the variables of pressure, volume, and temperature. The process of changing at least one of the parameters from pressure, volume, and temperature is called thermodynamic process. I am running faster because this is a simple thing. You have three variables: pressure, volume, and temperature. At least one of them, if you can change, then this is known as thermodynamic process. What is the meaning of at least? You can change two, you can change all three. So whatever may be the situation, but it is going to be called as thermodynamic process. So there are various types of thermodynamic process that you should remember. And I hope that after this discussion, you will remember. First is isobaric process. Whenever you see iso term, it means constant. ISO means constant. Baric or bar is used in terms of pressure. So isobaric process is the process in which pressure remains constant. The process in which pressure remains constant. All other variables or other parameters can change, but pressure will remain constant. That's the thing. This is called isobaric. Similarly, isochoric process. ISO means constant. Choric is generally used for volume. So the process in which volume remains constant is known as isochoric process. Another thing, isothermal process. You can easily understand the isothermal process, the process in which temperature remains constant. Very simple things. So you have learned three processes: isobaric, isochoric, and isothermal process. There is one more process that is known as adiabatic process. Adiabatic, you can remember that adiabatic, the walls we have used. Adiabatic walls, what they do, they just cannot transfer heat. So adiabatic process is what in which heat transfer cannot take place. So no heat transfer takes place in the adiabatic process. So these are the four basic processes. There might be some other terms you will see as process, like you will see cyclic process, you will see quasi-static process, you will see reversible, irreversible process that we will discuss later on this stage. These are the four fundamental processes you will see, basic processes. So I think you can remember these four terms because in the next concept test, I'm going to use these terms. Till now, everything is sorted. Thermodynamic variables, pressure, volume, temperature. If you can change any of these, at least one of them, then it is known as thermodynamic process. Thermodynamic processes are of basically four types on your screen. Moving further. Indicator diagram. Now our physics starts of thermodynamics. Indicator diagram. Generally, the indicator diagram, why they are called as indicator diagram and what are indicator diagrams? So the simple definition is the graph between any two parameters out of P, V, and T. There is pressure, volume, and temperature. So any two, दो के बीच में graph, it may be PV graph, it may be pressure temperature graph, or it may be volume temperature graph. These are the three configurations that you can make out of these three. Either pressure volume, pressure temperature, and volume temperature. So any of these three graphs is known as indicator diagram. Clear. I think definition is clear. Indicator diagram. Like this is an indicator diagram on a screen. This graph is drawn between pressure and volume. So this is of first category, pressure and volume. Second may be pressure and temperature. Third may be volume and temperature. No other configuration is possible. So PV, pressure and volume graph. Now, how to read this? How to read this graph? Listen to me. Now, listen to me each and every point. Let's suppose this is a graph. Point A and point B. Whenever there is an indicator diagram, there will be an arrow on the graph. This arrow will indicate the process. This arrow will indicate the process. So this arrow says process is from A to B. Process is from A to B. This is indicated by this arrow. And if you see, if you are moving from A to B, this is A, this is B. Can you see that at A, the volume is, let's suppose V1. At B, volume is, let's suppose V2. Can you see that volume is increasing? Volume is increasing. So what we can conclude that this is expansion. This is expansion of the gas. In this process AB, the expansion is taking place. I think it is clear. Why it is called indicator diagram? Because it is indicating the process AB, how the process AB is happening. Why the what's happening in the indicator, what's happening in the process AB. So what's happening here? The expansion is happening here. There might be another graph you can see. This is again a PV graph. Again, this is indicating the arrow in this direction. So the process will be again A to B. Process is again A to B. Now what's happening? You can see if you move from A to B, pressure is, sorry, volume is increasing or decreasing. You will say volume is decreasing. If volume is decreasing, then it is known as compression. It is known as compression. I think it is clear now. So there might be VT graph, there might be PT graph. We will discuss each of the graphs while we will discuss the processes. So right now, it's important for you to solve a concept test. The concept test is very important for you now. I think there is a need of concept test. Okay. So the question on your screen is you will need actually, I think, 40 seconds to solve it out. 40 seconds will be enough. What the question says, identify the process from the indicator diagram. So this is the indicator diagram. Comment, everyone should comment that what is the process happening here. Options are isothermal, isochoric, isobaric, and adiabatic. JNV Pune, JNV Krishna, JNV PKD, and uh, JNV RR, JNV PKD2. You all should try to answer the question. How many of you are more comfortable in Hindi than the English? Can anyone say yes, no? Can anyone write in the chat box? How many of you are more comfortable in Hindi than the English? No one? No. JNV are okay. Can you just answer is C? Okay, isobaric. Okay, JNVRR. I will see. What is the full form of this RR? May I know? JNVRR. RR means in which state this JNV belongs? Telangana. Okay, okay, okay. Okay, so the question, if you see the graph is between volume and temperature. The process is AB, and they have shown a dotted line there, which is to show that process, if you continue it, it will start with the origin. So this is a y equals to mx plus c line, y equals to mx, you would say. So in this situation, you will conclude that volume is proportional to temperature. This process, for this process, volume is proportional to temperature. From the indicator diagram. Now, we have a PV is equals to nRT. Now, listen to me very carefully. Out of this, R is a constant, which is gas constant. Now, they are saying that V should be proportional to T. If V should be proportional to T, what does it mean? That pressure should also be constant. Pressure should also be constant. And if pressure is constant, then the process is known as isobaric process. Process is known as isobaric process. So if the process is isobaric, then option C is correct. And I think JNVRR, you have answered correct actually. This is isobaric process. Very good. Now, if you have learned the concept, then you can solve one more easy question, easy peasy type of question on your screen. The same type of question, but the graph has changed, the parameters has changed. This is between P and T. Try to solve it out. You have 30 seconds. Be quick to answer. B. Okay, let's see. Everyone, Preetham from JNV Pune is giving answer C of the previous question, I think, na? Okay. So again, the same thing. You can easily solve that. From this graph, you can see that P is proportional to T. And we know the relation PV is equals to nRT. Again, identify the given constant things that nR is a constant. P should be proportional to T. If P should be proportional to T, then all other things should be constant. So V should be constant. And if V should be constant, then V is what? This is isochoric. When volume is constant, then process is known as isochoric process. So correct option is B. Very good. JNVRR. You have answered very well. Now, this is a basic question. I think this was the homework question, I think. I have solved it here. No issue. We will move further. Now, the basic main concept will start, that what is the work done by the gas. There might be a confusion between the student if you have studied thermodynamics in chemistry. So just leave it aside. Otherwise, you might get confusion. You might be confused in that situation. So just leave it aside. What we are going to do, we are going to calculate the work done. Remember the thing, work done by the gas. Okay. Let's suppose there is a thermodynamic system. There is a thermodynamic system in which the piston is at the position A and the ideal gas is filled in it. And at the position A, when the piston is at position A, the pressure here is P1, volume is V1. Okay, A. This is the answer of the previous question. I think you are answering, na? JNV PKD. Uh, you can check. I think the answer was not A. It was B actually. Na? So I have cleared the concept there. Okay, so please tell me, everyone, is everything okay now with the screen? Is there any lag you were feeling in my voice or screen? Is there anything kind of? Then tell me. So what I am saying, that in the thermodynamic system, piston is at A and at this position, pressure is P1, volume is V1. Now the gas expands. Just suppose that gas expands and the piston moves to position B. And the pressure and volume at this position is P2 and V2. Clear? There might be some temperature T1 and T2 as well. So we will not fight over that. That why is the temperature you are not mentioning? It will be T1 and T2. Okay. So we need to calculate the work done by the gas in this process from A to B. So for the calculation of work done, I have taken a very small displacement in between. Very small displacement is from C to D. And this displacement, let's suppose, is dx. And during this small displacement, what I'm saying, during this small displacement, the pressure is constant. And this pressure is P. What I'm assuming, that during this small displacement, pressure does not change because the displacement is infinitely small. So pressure remains constant, that is P. Clear? So first of all, I will calculate the work done in a small displacement. I am assuming one thing, that the area of this piston is A. Area of this piston is what? A. So work done will be. So I will write work done in small displacement from C to D. You will say that work done will be force into displacement. And for the displacement, you need to apply the force in this direction. Na? So displacement will be force into displacement, angle will be 0. So I am now not writing cos 0 equals to 1. So work done is equals to force into displacement. What is the force? Force is what? We know that P is equals to force per unit area. So force is P into A. P is the pressure, A is the area of cross section. So work done will be, if you see at this position from C to D, pressure is P. That is P into area of cross section we have taken as A into dx. This is the small work done for the small displacement dw. Now, you can see that what is A into dx? A is the area of cross section. A is the area of cross section. Dx is the length. Can you see that this CD portion is a cylindrical portion? If this CD portion is a cylindrical portion, then area of base into height is what? Volume. So this dw will become P is there and A dx is nothing but the volume. This is small volume. Let this small volume is dV. A is this is cylindrical portion you can see, I think. CD is a cylindrical portion because this vessel is cylindrical. Area into height, base area into height is what? Volume. So PdV. This is the work done in a small displacement. So complete work done from A to B will be work done is equals to, you will integrate it PdV. If you are integrating it with respect to volume, then you should put a limit in terms of volume, and limit in terms of volume is V1 to V2. From V1 to V2. This is what work done by the gas. This is a very basic fundamental formula that you should remember, that work done by the gas is PdV, PdV, integration PdV. Here P is the pressure, dV is the volume change, small change in volume. Now, there are 2 or 3 more things that you should remember. The punchlines I will say. Listen to me. If you can see what I have mentioned, that gas is expanding here. You can see the piston is moving from A to B. So you can see that gas is expanding. Whenever the gas is expanding, we will say work is done by the gas. Listen to me very carefully. If we talk about expansion, what is the meaning of expansion? What will be the meaning of expansion? If you see that expansion PdV, if you put the limit V2 minus V1, gas is expanding. That means work is done by the gas. Work is done by the gas. And this work done is considered positive. So remember one thing, whenever there is expansion, what does it mean? That work is done by the gas. And if work is done by the gas, it will be considered as positive, or not considered, it will be calculated as positive, because change in volume is positive. V2 minus V1 will be positive because of the expansion. V2 is more than V1. One thing is clear. Second thing, if the compression takes place, gas will not contract itself. You have to compress it. So whenever there is compression, what does it mean? Work is done on the gas, and this work is calculated as negative. This work is calculated as negative. Clear? Now, I think we willing to create a confusion in your mind, but there must be a thing that you after the discussion, after knowing the formula, there might be a question. Listen to me very carefully. There might be a question in the exam because most of the errors are caused by the plus and minus sign in this chapter, in this particular topic. So listen to me very carefully. What we were calculating work done by the gas. Listen to me carefully. We were calculating work done by the gas. In some questions, it may be mentioned, it may be asked that work done by the external agent. Calculate the work done by the external agent. Clear? So what I'm saying that work done by the external agent will be same in magnitude for the work done by the gas, but there will be a negative sign. There will be a negative sign. So the work done by the gas is positive. If the work done by the gas is positive, then work done by the external agent will be negative in that situation. This is another most important thing. You might get confused. You might get confused. Ki, sir has told me that expansion has positive work done, but why this book is referring that work done in expansion is negative? Because they are calculating work done by external agent. Try to keep these things in your mind. I think everything is sorted till now. If I say, answer me. If I say a gas is expanded, a gas is expanded. Calculate the work done by the external agent. Will it be positive or negative? What you know that whenever there is expansion, work done is positive, but you forgot by the gas is positive. And what I am asking by the external agent, so it will be negative. Clear? Moving further. I think time is over actually. I think your chemistry class is scheduled. So I just cannot move further. I can create one more situation for you. I think this topic should be ended here. Okay. Let's suppose what we are going to do. We are going to calculate the work done using PV diagram. PV diagram is known as indicator diagram. So let's suppose there is a PV graph. This is a PV diagram. Okay. What we have calculated till now, what we know that work done is what? Integration PdV from V1 to V2. This is what we know. Now suppose there is a thermodynamic process AB. At A, again the same data I am taking. At A, pressure and volume are P1 V1. At B, pressure and volume are P2 V2. Clear? Let's consider a very small portion on this graph. Very small portion on this graph. This is looking, it might look very large to you, but this is very small portion. During this small portion, let's suppose CD. Again, during this small portion CD, the pressure is constant. Let's suppose the pressure is constant, which is P. And this change in volume is dV. If this pressure is constant, then you can see that it will look like some rectangular strip. It will look like some rectangular strip. Then area of this rectangular strip, area of rectangular strip, small area will be dA. What will be the area of this rectangular strip? You will say length into width, length into width. One side is dV, another side is P. Because on y-axis, what we are calculating, we are measuring P. On x-axis, we are measuring volume. So volume is what? dV. Pressure is what? P. So that will be PdV. This is the area of the smaller rectangular strip. You can break this out in very large number of strips like this. So you have learned this in basic mathematics. If you want to calculate this total area, then you need to integrate it. If you want to calculate total area, so total area A is what? Integration PdV. From where to where? From point A to B. So this PdV, integration PdV is nothing but the work done. So what you can conclude here, this is nothing but the work done. So what we can conclude here, work done, or I will write it in more precise way, that area, you need to make it a punchline. Area under PV diagram with which axis? With volume axis gives done, gives work done. Now again the same thing. You can calculate the area, but how to choose the sign, whether it will be positive or negative. So you have to choose it by the greater arrow. If expansion is there, work done will be positive. If compression is there, work done will be negative. So area under the PV graph with the v-axis gives work done. Gives work done. You need to keep it in your mind. You need to make a punchline of that. So I think everything is sorted now. Time is actually up. So take your chemistry class. Till then, enjoy everyone, and we will discuss few more topics, few more interesting topics later in this class. I hope you got everything. So bye everyone.